Have you ever looked up at the night sky, far from the glare of city lights? You see a smear of light, a soft glowing band stretching from one horizon to the other. Our ancestors gave it a name, the Milky Way. They saw it as a celestial river, a path for the gods. But we know what it really is. It's our home galaxy, seen from the inside out. And that beautiful milky glow is not a cloud. It is the combined light of billions upon billions of stars, each one a sun, many perhaps with their own families of planets. How many stars are we talking about? How many suns share this galactic city with us? The truth is, we don't know the exact number. We can't just count them one by one. Imagine trying to count every grain of sand on all the beaches of the world. Now imagine doing it while you're buried in one of those beaches, able to see only the grains closest to you. That's our predicament. We live inside the Milky Way, about 27,000 light-years from its dazzling, chaotic center. Our view is obstructed. Great clouds of interstellar dust, interstellar gas, the very stuff from which new stars are born. We are cosmic city dwellers, trying to guess the population of the entire metropolis without seeing most of its streets. So we estimate. Laws of physics, powerful telescopes, cosmic detective work. The current best guess, between 100 billion and 400 billion. Astronomers can estimate the total mass of the Milky Way. They do this by studying how fast our galaxy rotates. Just as the sun's gravity keeps Earth in orbit, the combined gravity of everything in the Milky Way keeps the stars from flying off into intergalactic space. By measuring the orbital speed of stars at different distances from the galactic center, this is where incredible tools like the European Space Agency's Gaia mission come in. Gaia is a space observatory with a singular purpose: to create the most precise three-dimensional map of the Milky Way ever made. For years, it has been tracking the positions, movements, and brightness of over 1 billion stars with astonishing accuracy. The huge uncertainty in our star count, that gap between 100 and 400 billion, is largely due to one type of star, the red dwarf. They are the smallest, coolest, and dimmest kind of star. A typical red dwarf might have as little as 8% of the sun's mass and shine with less than 1/10,000th of its brightness. They are cosmic embers, glowing faintly in the dark. Because they are so dim, they are incredibly difficult to detect, especially from thousands of light years away. It's like trying to spot a candle from across an entire country. Despite their faintness, red dwarfs are the most common type of star in the universe, by a long shot. We estimate that they make up about 75%, or 3/4, of all stars in the Milky Way. Think about that. For every star like our sun, there are at least 3 of these tiny, dim red dwarfs hiding in the shadows. They are the true rulers of the galaxy. Their sheer numbers mean they have a huge impact on our estimate of the total star count. If our models predict a slightly higher percentage of red dwarfs, the total number of stars in the galaxy shoots up dramatically. Because red dwarfs are so small and cool, they burn through their hydrogen fuel at an incredibly slow rate. A star like our sun will live for about 10 billion years, but a red dwarf can live for trillions of years. That's far longer than the current age of the universe, which is a mere 13.8 billion years old. This means that every red dwarf star that has ever been created is still shining today. Not a single one has had enough time to burn out. They are the oldest, most patient inhabitants of our cosmos, silent witnesses to the entire history of the universe. So when you look up at the night sky, remember what you're not seeing. The thousands of stars visible to your naked eye are mostly the big, bright, and relatively rare ones. They are the galactic superstars. But they are a tiny fraction of the whole story. The true population of our galaxy is a hidden multitude of faint red suns. They are the quiet, unassuming citizens that fill the vast, dark spaces between the brighter stars. Our galaxy is a city whose population is mostly invisible. A sky filled with ghosts that we can only detect with our most clever instruments and our most imaginative minds. To truly grasp the scale of our own galaxy, it helps to look at our neighbors. The Milky Way isn't alone in the cosmos. It's part of a small cluster of galaxies called the Local Group. Our biggest and closest neighbor is the Andromeda galaxy, also known as M31. You can even see it on a clear, dark night as a faint, fuzzy patch of light. Andromeda is a cosmic heavyweight. It's slightly larger than the Milky Way and contains significantly more stars. Current estimates suggest that Andromeda is home to as many as 1 trillion stars. It's our big sister galaxy, a sprawling metropolis of light just 2.5 million light-years away. But not all galaxies are behemoths like the Milky Way or Andromeda. Our local group is also home to dozens of smaller dwarf galaxies. The Large Magellanic Cloud has around 20 billion stars. The Small Magellanic Cloud has a mere 3 billion. In about 4.5 billion years, they will begin a slow, majestic, and transformative collision. Over hundreds of millions of years, the two galaxies will merge, their stars intermingling in a gravitational dance. Our local group is just one small cluster of galaxies. The observable universe contains an estimated 2 trillion galaxies. If we take our Milky Way's low-end estimate of 100 billion stars and multiply it by 2 trillion galaxies, we arrive at a truly staggering number of stars in the universe. There are more stars in the observable universe than there are grains of sand on all the deserts and beaches on Earth. It's so large it defies analogy. On the clearest, darkest night, away from all the pollution of artificial light, the human eye can see about 2,500 stars. Some accounts push this number closer to 5,000 if you count both hemispheres. That's it. 5,000 stars out of the 100 billion or more that populate our galaxy. This means that for every single star you can see with your own eyes, there are at least 20 million stars in our galaxy that you cannot see. They are far too faint, hidden behind impenetrable curtains of cosmic dust. Your naked eye view of the cosmos is just a tiny, sparkling peephole into an unimaginably vast reality. The light from these stars has taken years, centuries, or even millennia to reach us. The light we see from Polaris, the North Star, left that star over 400 years ago. When you look at it, you are seeing it as it was during the time of Galileo. The light from the Andromeda galaxy began its journey 2.5 million years ago, when our own human ancestors were first walking the plains of Africa. The night sky is not a snapshot of the present, it is a time machine. We are looking at a gallery of ghosts, a collection of stellar memories whose light is only now reaching our eyes, whispering tales of a distant past. This cosmic perspective is, I think, a deeply humbling and exhilarating one. It reminds us that the universe is not about us. We live on a small, rocky planet orbiting a rather average star, tucked away in a quiet spiral arm of one galaxy among trillions. And yet, we have the capacity to understand this. Our minds, born of stardust, have developed the tools of science to reach out and comprehend the scale of the cosmos. We can estimate the number of suns in our galaxy and chart the course of its future collision with another. So the next time you look up at the stars, don't just see them as beautiful points of light. See them for what they are, a tiny, visible fraction of a colossal, hidden city of suns. Feel the immense weight of those invisible billions, the quiet hum of the red dwarfs, the vast distances that separate us from our galactic neighbors. Let it fill you with a sense of wonder, because the quest for knowledge, the drive to understand our place in the universe, is the noblest adventure of our species. The cosmos is waiting. There is so much more to discover.